is a photovoltaic or solar cell. It's designed to convert sunlight into electricity. One cell on its own won't get you very far. They're usually set up in groups or arrays. Arrays are often mounted on buildings or set up in open spaces. The more cells you have and the more sunlight you have, the more electricity you can generate. You can use this electricity to run something, such as a toaster, until the sun goes behind a cloud. A more practical idea is to connect the array to batteries. There are many ways to use this technology. Photovoltaic cells, or PVs as they're often called, supply power to parking meters, street lights, and buildings large and small. They are often used in conjunction with other electricity sources. Arrays for large-scale power generation can be huge. Big ones, on a scale like this, are called solar farms. But whether you have 10 cells or 1,000, the principle is the same. Each cell is made of 4 main components: a top layer of glass, a silicon wafer, a backing layer, and conducting materials linking each side of the silicon wafer together in a circuit. Most PV cells are silicon-based. Silicon is chosen for its semiconducting potential and easy availability. The silicon wafer is very, very thin. Here's a close-up. Each side of the wafer has been treated differently. These treatments affect the behavior of the electrons in the silicon atoms, creating an electrical field at the internal interface. One side has more loose electrons bouncing around and is negatively charged. The other has more atoms with holes in them where electrons could go. This side is positively charged. Now let's put the PV cell in the sun. Sunlight is made up of streams of particles called photons, which are units of electromagnetic radiation, in other words, a form of energy. When the photons penetrate the silicon wafer, they give loose electrons they encounter extra energy, enough to enable the electrons to move across the electrical field. Electrons begin to flow through the wafer and round the circuit. The direction they move in depends on how the circuit has been set up. So now we have a flow of electrons, in other words, electricity. We can harness the electricity by incorporating something we want to run, such as a light bulb, into the circuit. Or we can place a battery in the circuit and store the electricity. Many PV installations incorporate a transformer in the circuit instead of a battery. This transforms the voltage to a suitable rate. The installation might also transform the PV-generated direct current to alternating current, which is more efficient and cheaper for cable transmission, even over short distances. A typical domestic PV installation in the UK has a capacity of between 1.5 and 3 kilowatts of power. This is enough to supply around half the average yearly requirement of a British household. Any extra power generated could be fed into the community's power grid, helping power other households. The more microgeneration sites you have, the less demand you place on the country's main power stations.